Today's lesson is about kites. Now, a kite is just a quadrilateral, so a shape with four sides, with two distinct pairs of congruent adjacent sides. Remember, adjacent kind of means right next to. So if you look at the picture of this kite, our two congruent sides are right next to each other. Same for this set. So that's what it means by adjacent congruent sides. Our theorem 6.2, says that if a quadrilateral is a kite, then its diagonals are perpendicular. Perpendicular means they meet at a 90-degree angle. So if you look at this picture on the right, our diagonals are the lines that go from one corner to another, so BD and AC. Basically, all of this theorem is saying is that the angles where the diagonals meet are all 90 degrees. They are all right angles, all four of them. And if we look a little closer, we can see that these diagonals create four right angles. So a lot of what we are doing today is finding angles of triangles, which you guys have done before, which is good. So if we have a kite, then the diagonals are perpendicular, creating four right angles. We're going to take a look at one other thing that happens with kites, dealing with triangles. So first of all, we are given kites ABCD. Remember, a kite, we have two sets of congruent sides with main diagonal AC. The main diagonal is the diagonal that cuts the kite symmetrically, or it's the long diagonal. So first of all, if I want to prove that triangle ABC is congruent to triangle ADC, which is what I want to do, I know that AB is congruent to AD, and that was given to us from the picture and the fact that we know it's a kite. We also know that BC is congruent to DC. If you look at the triangle at the top and the triangle on the bottom, so we're looking at this triangle and this triangle, you can see that they share a side, that side in the middle, which is AC. And obviously, AC is congruent to itself. So AC is congruent to AC. Mark that in my picture. And we know that because of the reflexive property of congruence. Hopefully this is coming back to you guys. Reflexive property of congruence. Now if you look at our picture, we have three sets of congruent sides. So triangle ABC is congruent to triangle ADC by side, side, side. Remember, that was one of our reasons for proving triangles congruent. We learned that at the beginning of the year. The reason I wanted to show you guys this is because now we know some things about some of the other angles. Since these two triangles are congruent, I know angle B corresponds with angle D, so those angles are congruent. Angle BAC, which is this angle right here, corresponds with angle DAC, so those angles are congruent. And then finally, angle BCA would be congruent to angle ACD. We know that because we have congruent triangles. So if we have a kite, we know that our diagonal, or our long main diagonal, splits this thing up into two congruent triangles. So we can use this to help us find some of the angle measures. So let's dive into our first example. We are going to find all 5 angles. So angle 1, 2, 3, 4, and 5. First things first, our theorem tells us that the diagonals of our kite are perpendicular. So I know that all 4 of these angles at my intersection are all 90 degrees. So that means angle 1 is 90 degrees and angle 3 is 90 degrees. Finding the angles where your diagonals meet is always a good start because you always know that they are 90 degrees. So now let's take a look at angle 2. Notice angle 2 is part of this top left triangle. We know one angle is 35, one angle is 90, and then this is our missing angle right here. If you guys think back to when you were finding missing angles of a triangle, that is all we're doing. So we know that the angles of a triangle add to 180. So for angle 2, I know that 35 plus 90 plus our angle 2 has to be 180. So we can add our 35 and 90 and then we could subtract that from 180 to find the measure of angle 2. So the measure of angle 2 is 55 degrees. So that leaves us with angle 4 and angle 5. Well, we know angle 3 is 90. And we need to figure out what we know about angle 4 or angle 5. So I'm going to do some highlighting. First of all, we know that this side is congruent to this side, because it tells us that's what those single marks means congruent. And then we also know that this side is congruent to this side. And then those two triangles, so the triangle on the top and the triangle on the bottom, share the side in the middle. So there are our two congruent triangles created by that long diagonal in the middle. Remember, that is what we proved. So, since this angle is 35, I know angle 5 corresponds to that angle. So, angle 5 also has to be 35 degrees because they are corresponding angles of congruent triangles. So just like angle 2 we can find angle 4 by adding the 35 degrees plus 90 degrees plus our angle 4. And since those are the 3 angles of a triangle, they should add to 180. So we end up getting the same thing. Angle 4 is 55 degrees. Next one, we're going to do the same thing. We're going to find angle 1, 2, and 3. So I'll write it out. I like to start with the angles by the intersection of my diagonals. So here are my diagonals, and I know they're perpendicular. So I know that angle 1 and angle 3 are equal to 90 degrees. So this is 90 degrees, this is 90 degrees. Now we have to find angle 2. First of all, let's remember that this main diagonal right here splits this kite into 2 congruent triangles. So if this angle is 64, this angle is also 64 degrees. So now since we have 2 of the 3 angles of this small triangle right here, we can solve for angle 2. So 64 degrees plus 90 degrees plus angle 2 has to add to 180. I know that 64 plus 90 is 154. Subtract that from 180, and angle 2 is 26 degrees. So all we were doing on this example was finding the missing measures of the angles of a triangle. Right. Next one, on this example we are finding x. So again, I'm going to make note that all of these angles at my intersection of the diagonals are 90 degrees. If I try to look at this angle, notice I only have information for 2 of these angles. So if I tried to set up an equation to solve for x, I would not have enough information. So let's look at this triangle down here. I know that this angle is x plus 6. This angle is 2x. And then I have my 90-degree angle. So we're going to use that to set up an equation to solve for x. So I know all 3 of those angles have to add to 180. So x plus 6 plus 2x plus 90 equals 180. If I combine like terms on the left-hand side, I know that x plus 2x is 3x. And 6 plus 90 gives me a 96 equals 180. And then we just solve. So subtract the 96 from both sides. So 3x is equal to 84. divide both sides by 3, and x is 28. Now, all we are doing on this example is finding x. If you were asked to find one of the angle measures, you would just take that x value and plug it in. On this example, we are only given one of the diagonals, and that is the long or main diagonal. Notice it cuts this kite symmetrically in half. So now we need to find x and y. First of all, if I wanted to find y, I don't have enough information on the left-hand side, so I think we're going to have to solve for x first. First thing we need to notice, this whole angle at the top is 90 degrees. Okay, it's the two angles added together. Well, I'm going to do some highlighting again. I know that these two triangles are congruent by side, side, side. So since the two angles at the top are congruent, so this angle and this angle, and they add to 90, both of these smaller angles have to be 45 degrees. So both of these smaller angles are 45 degrees because it's half of 90. So if we look at our triangle on the right-hand side, or the blue triangle that I highlighted, we have information for all three of those angles. So I'm going to use that to set up an equation. So 45 plus 6x plus 3x over 2 should be equal to 180. I can add like terms. So 6x plus 3x over 2 gives us a 15x over 2. And then we could subtract the 45 from both sides. So 15x over 2 is equal to 135. Now, we need to solve for x. So I need to get rid of this 15 halves. What you could do is multiply by the reciprocal. You guys might have heard this in algebra. Reciprocal just means you flip the fraction. And when we do this, we now have a 2 on the top and a 2 on the bottom. So those cancel. And then we have a 15 on top and a 15 on bottom. So on the left-hand side, we are just left with x. 135 times 2 over 15. If you type that into your calculator, it's going to give us an 18. So x is equal to 18. And now we need to think about how this will help us find y. Well, y is this angle right here. And I know that it is congruent to this angle because they are corresponding parts of our congruent triangles. So y is equal to 6x, or 6 times 18, and 6 times 18 gives us 108. So x is equal to 18, y is equal to 108. The last example I have for you is actually number 20 on the worksheet. Now notice that it does not give us the diagonals. So we are not dealing with triangles, we are just dealing with the kite. Well, if I were to have an imaginary main diagonal, I know that it would divide this kite into two congruent triangles where angle 1 was congruent to angle 2. So if I know that angle 1 is congruent to angle 2, I could use this to set up an equation. So I'm going to call angle 1 and angle 2 x, because they're the same. If angle 1 is x, angle 2 is x. Now think back to what we learned Monday. I know that the sum of the angles in a quadrilateral, so just a four-sided polygon, is 360 degrees. If you forgot that or didn't know that the angles add to 360, remember our angle sum formula was 180 times n minus 2. And in this case, our n would be 4 since we have 4 sides, which gives us a 180 times 2 or 360. So I know that all 4 angles of my kite have to add to 360. So that gives me an x plus 101 plus 48 is equal to 360. X plus x is 2x. 101 plus 48 is 149. If we subtract the 149 from both sides, we get 2x is equal to 211, and then we would divide by 2. So x is equal to 105.5, meaning both angle 1 and angle 2 are 105.5. So that is how you would solve a kite where it does not give you the diagonals. And that is all I have for you today.